Yeah, hi everyone. This is Gnaneshwarachari, Faculty of Chemistry in Residential Degree College. Today we are going to discuss about chemistry. In this chemistry, today we are discussing about coordination complexes or coordination chemistry. That is very important topic, and yes, that is coordination chemistry. In this coordination chemistry, actually it is very important topic. Everybody knows that. Yes, in state universities like University and Kakatiya University, and these state universities carries 10 to 12 marks, and BHU Benares Hindu University, HCU Hyderabad Central University, JNU Jawaharlal University, and Delhi University, like these central universities carries around 5 to 6 marks. So that's why this is a very important topic, and uh, it carries maximum marks. So when we are discussing about any topic, just we need to know about fundamentals about regarding the topic. So what is the fundamentals here? First of all, we need to know about definition. What is the definition of coordination chemistry? Actually, coordination chemistry deals properties of it explains properties of transition metal. Transition metal means nothing but metals comes under D block elements and F block elements. But here we need to discuss about proper definition, like which explains a chemistry which explains properties of transition metal. A chemistry which explains properties of transition metal complexes is called as coordination chemistry. It means simply here a chemistry which explains properties of transition metal complexes is called as coordination chemistry. It means it explains about properties of transition metals. That's it, simply. It means what is the phenomena is going here in complex compound. In complex compound, it carries every complex consists metal and as well as ligand. Actually, the phenomena here, metal accept a pair of electrons and a ligand donate a pair of electron. These phenomena takes place in this coordination complex. First of all, we need to know about representation of coordination complex. Representation of coordination complex is must required, because representation of complex compound is nothing but here when the metal is reacts with ligands, that is x number of ligands, it gives rise to mlx plus or minus n. Here m means nothing but here metal. Here L means simply ligand. Here X means coordination number. Coordination number means nothing but number of ligands. That's it. N means plus or minus N means here it is oxidation state. So yes, what is the meaning of this complex? It means what is the meaning of here this square bracket means this square bracket is known as coordination sphere. Coordination sphere. So this is a representation of complex compound. Here in coordination complex, M means metal, L means ligand and X means coordination number. That is a coordination number. Coordination number means nothing but number of ligands. The total number of ligands is called coordination number. Here plus or minus n means oxidation state. This square bracket is known as coordination sphere. Are you able to following my words? Please yes, accept my knowledge and accept my class, because of it helps you, it useful to you who are interested to write JRE TOEFL, not JRE TOEFL. Sorry, it is useful to MSET, NEET, and MSc entrances. Actually, recently we are started for PG coaching in my college, so it is very useful class to all. And right, this is the representation of a complex compound. Come to the topic. Yes, here we need to know the nomenclature of coordination complex here. So right, after that, yes, nomenclature of coordination complex. Nomenclature of coordination complex means here nomenclature of coordination complex or complex compound, whatever it is. First of all, every coordination complex consists metals and as well as ligands. We know that. Okay. But here, according to IUPAC method, according to IUPAC, that is called IUPAC method, following rules are used to give the name for metal complexes. We have some rules. That one, that is Roman letter 1, that is order of naming of complex. Order of naming of complex. Order of naming of complex means here, yes, simply if given complex is ionic complex, if given complex is ionic complex, ionic complex means nothing but it consists cationic sphere and as well as anionic sphere. It means if the given complex is ionic complex, how to write the name of this coordination complexes? So what I am saying here, if given complex is ionic complex, then first write the name of cationic position sphere followed by anionic position sphere. Here I am giving you simple logic. For example, NaCl, Na is a cation, Cl is a anion. Here first we are writing cation name followed by anion name. And one more example, sodium hydroxide, Na is a cation, OH is a anion. First we are writing name of cationic position followed by anionic position. It means these names, every name is made by IUPAC method. Okay, in terms of IUPAC method, here if given complex is ionic complex, it means it is consist cationic position sphere and anionic position sphere. Just write the name of cationic position sphere followed by anionic position sphere. This is the fundamental rule of order of naming of complex. Okay, when you are writing name of cation and anionic position sphere, just leave a single space between the cation and anion. Are you understanding? If you have any queries, please comment on comment box, and I will clarify, and definitely Yes, this is the concept. When the given complex is ionic complexes, just write the name of first cationic position pair and followed by anionic position pair. So leave a single space between both the names. It is a cation and anion. These is the fundamental rules of IUPAC. And the second rule is nothing but naming of coordination complex. Naming of coordination complex means here, if coordination sphere consists, actually we know that every coordination complex consists metal and as well as ligands. Okay, it means to write the name of coordination complex, first give the name of ligands followed by name of metal. It means every coordination complex consists metal and as well as ligand. Is it clear? Okay, when you are writing about name of coordination complex, just write the name of ligands first followed by metal. So right, when you are writing the name of metal, just put a oxidation state, metals oxidation state within a bracket by using Roman numbers. Okay, simple technique. When you are writing name of coordination complex, just write the name of ligands followed by metal. When you are writing the name of metal, metal name, yes, when you are writing the name of metal, represent the oxidation state of metal within the brackets by using Roman numbers here. And then we have to write the naming of ligands. Naming of ligands means most of the neutral ligands named as it is in organic chemistry and as it is in inorganic chemistry. For neutral ligands, there is no argument, there is no discussions about neutral ligands. Only we have discussion about positive ligands and negative ligands. For neutral ligands, for example, NH3, same as is treated as a organic and inorganic chemistry, that is amine. NH3 in coordination chemistry, it is a amine. H2O in coordination chemistry pronounced as a aqua. CO, it is a carbonyl. CS is a thiocarbonyl. There is no discussion, there is no argument. But here what I am saying, for positive ligands, the positively charged ligands always ends with the word em. We have some clue here. It means every positive ligands, for example NH4 plus, that is ammonium, it is ends with the word em. And H3O plus, it is hydronium, it is ends with the word em. It means simply the positive ligands are ends with the word em. And negative, what about negative ligands? And we, for negative ligands also we have some clue. Every negative ligands ends with a letter O, like CO3 minus 2, carbonato ends with a letter O. And OH minus, that is hydroxo, H minus, that is hydro or hydrido ends with the letter O. Cl minus, chloro ends with the letter O. These ligands are called negative ligands. It means neutral ligands, there is no discussion, there is no argument. It is as it is in inorganic chemistry, as it is in organic chemistry. But for positive ligands are ends with a letter, ends with the word em, like ammonium, hydronium, etc., etc., etc. Negative ligands are ends with the letter O, carbonato, hydroxo, hydrido, chloro, like this. So what I am saying here, ligands are classified In classified depends upon charge. Depends upon charge. Ligands are classified into three types. That is the neutral ligands, the positive ligands, and negative ligands. Okay. So here we are discussed about classification of ligands also here. Right. Right. We know that already. If ligands are ambidental ligands means, do you know about ambidental ligands? Ambidental amphibians. It means both. What is the both? Both here, for example, ambidental ligands. Ambidentate ligands. For ambidental ligands, what happening here? Ambidental ligands means the ligand which is having more than one donor atom, more than one donor atom, but it utilizes only one donor atom, but utilizes only one donor atom are called ambidental ligand. For example, CN is called cyano. Here NC is called isocyano. It means in this carbon is a donor atom in cyano. Here nitrogen is donor atom in isocyano. It means simply what I am saying here, these ligands are having more than one donor atom, but it utilizing only one donor atom. These ligands are called as ambidental ligand. For example, one more thing, NO2 is a nitro, ONO is a nitrito. It means these are ambidental ligands. Here donor atom is a nitrogen, here donor atom is a oxygen. In nitro, donor atom is a nitrogen. In nitrito, donor atom is a oxygen. It is having same molecular formula, but what is the difference here? The donor atom is different. It means the ligand which is having more than one donor atom, but it utilizes only one donor atom is called ambidental ligands. Okay, so that's why what I am saying here, when you are writing about name, when you are writing the name of ambidental ligand, after writing the name of ambidental ligand, represent donor atom, represent donor atom symbol, represent donor atom symbol within brackets. For example, when you are writing cyano, just write the name of cyano, represent the symbol like a carbon. When you are writing name of isocyano, represent the name of nitrogen here. So just represent the donor atom symbol within a bracket here. So this is the complication of ambidental ligand. And one more thing, if ligands are we know that monodental ligands and bidental ligands, polydental ligands, depends upon the dentation. Ligands are classified into three types, so we know that. Okay, ligands depends upon the dentation, monodental ligand, bidental ligand, polydental ligand, depends upon the dentation. It means monodental ligands means the bond between metal and ligand is only one. Here the bonds between metal and ligand is 2. Here the bond between metal and ligand is more than 2. This is called polydental ligand. So here what I am saying, if ligands are having, for example, monodental ligands, if monodental ligands consist more than one time, how can we represent? For example, NH3 ligand. What is the name of NH3 ligand? It is a neutral ligand, monodentate neutral ligand. So we are saying it is a amine. But if NH3 is this coordination pair consists NH3 as a twice, we can use some prefixes here, diamine, that is diamine. If NH3 ligands are consist of 3 times, we can use triamine. If NH3 ligands are consist of 4 times, we can use tetraamine. So what I am saying here, if monodental ligands are consisted more than one time, we can use some prefixes like di, tri, tetra, penta, hexa, like that. Okay, if it is 2, we can use di. If it is 3, we can use tri. If it is 4, we can use tetra. Then what about polydental ligands or bidental ligands? So for polydental ligands, if polydental ligands are consist more than one time, we can use another prefixes like if polydental ligands are having more than one time, like 2 times, we can use prefix like bis. If polydental ligands are more than one time, it means 3, we can use prefix that is tris. If 4, we can use tetrakis. If 5, we can use pentakis. If 6, we can use hexakis. If 7, we can use heptakis. These are prefixes. Okay. If monodental ligands are there, we can use di, tri, tetra, penta, like that. If polydental ligands are there, we can use bis, tris, tetrakis, pentakis, hexakis, like this. So what I am saying here, right, when you are writing the name of polydental ligands, so which is writing note for polydental ligands. After using above prefixes, write the name of ligand within a bracket. For example, M metal consists En2 ethylene diamine. En means ethylene diamine. It is a bidentate neutral ligand. Okay, it consists of some charge like a plus N. These polydental ligand having more than one time, like 2, then we can use bis as a prefix. After writing bis, ligand name should be in bracket, that is ethylene diamine, then close the bracket. Are you able to following my words? Please concentrate on this topic. It is very 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 important, and it carries maximum marks. And next one, this is about ligands and how to write the name of metal. Naming of metal means for example yeah for metal, it is very interested when we are writing about when we are writing a naming of metal, because everybody knows coordination complexes are 3 types with respect to charge. If coordination pair carries a positive charge or negative charge, or doesn't carry any charge, that is no charge. Okay, actually we have 3 complexes. For example, if complex doesn't carry any charge, if complex consists positive charge, if complex consists negative charge. It means what I am saying here, if coordination sphere carries negative charge or positive charge, is if it is doesn't carry any charge, we have different rules when we are writing name of complexes. For example, if metal is present in this metal, if metal is present in this coordination sphere, and if metal is present in this coordination sphere, there is no argument, there is no discussion, write the name of metal as it is in periodic table. Are you able to understanding my words? Please concentrate on this words. If metal presented in this complex or this complex, okay, it means neutral complexes or cationic complexes, just write the name of metal as it is in periodic table. But here, if metal present in this complex, it means anionic complexes. Here what happens, actually when metal present in anionic complexes, here metal name ends with the word 8. It means metal name ends with the word 8. If metal is present in anionic complexes, metal name ends with the word 8. For example, if metal is Fe, we can pronounce as a ironate, ends with a word 8. If it is platinum, if platinum is presented at anionic complexes, we need to write as a platinate, cobaltate, nickelate, like that. Okay, this is the naming of metal complexes, and we have special rule and recently added rule, that is for example, if hydrogen is present in cationic positions, for example hydrogen um, hydrogen, platinum, NH3, hydrogen, platinum, NH3 taken 4. It means what is happening here, for these compounds or for these ligands and for these complexes, if hydrogen is present in cationic position sphere, what happening here, actually if hydrogen present in cationic position sphere, then no need to write the name of hydrogen. Actually what is the rule here, first rule, order of naming of complex, in that actually we are discussed that first of all we need to write the name of cationic position sphere, after that followed by anionic position sphere. But here there is no discussion about hydrogen, don't need to write the name of hydrogen here, just write the name of metal. Okay, but here what is the condition, the metal name ends with the word ic acid. Don't need to write the name of hydrogen, but here write the name of coordination complex. But here the condition is metal name ends with the word ic acid. For example, what is the name, tetraamine platinic acid, tetraamine platinic acid. In generally, how can we write hydrogen, single space tetraamine platinum. But here we are writing as it is. We don't need to write the hydrogen name, just write the name of coordination complex tetraamine, but instead of platinum we can we need to write as a ic acid. Acid means nothing but here hydrogen, we are representing hydrogen here as a acid. Okay, so that's why we are using ic acid. And right, this is the nomenclature of metal complexes. If any doubts or any queries, please ask in comment box. Thank you. Thank you everyone.